Hello, everyone. Thanks for coming. Did you know that 69% of the IT projects in the world fail? When I say fail, I mean they will be over budget, over schedule, simply stuck, or even worse, giving up. What kind of project, and I would say before, why this figure is so high? We can think at first seen about project management issues, organizational matters. However, something we miss and we forget most of the time is how we fully pinpoint and evaluate the technical constraints, the famous non-functional requirements. What kind of project we can find in this category? For instance, an European government which would like to create a sensitive data repository for its population. And it was really ambitious during the first steps. They would like to store 40 terabytes for 40 million active users. I like to guess how they made the correspondence between these two figures. However, after a couple of years, we only got 1 million registered users and just a bunch of data. Why this project does belong to this category, to this 69%? Because it was over-complex regarding the user needs. And most of the time, when your project is over-complex in this such situation, it ends being over-budget, over-schedule, or even worse. Why this complexity? Perhaps the requirements were too nebulous, or the risks weren't very well managed, either the technical risk or the human risks.
We can say that, of course, with a sensitive data repository, you have a lot of business rules. It's a very complex project. So, of course, if anything goes wrong at the non-functional requirements level, this will be a mess. It's also true for simpler projects. Simpler being relative, but let's say, again, these are examples that are based on true stories, on true nightmares that we had. Let's take the example of a website that allows you to book tickets for your next concert. The business rules are pretty simple. I choose the date, I choose the venue, I pay, and that's it. There is a little more complexity about that, but it's not quite as complex as a sensitive data repository, for example. Yet still, maybe you tried to book a ticket to some venues and you face this as a customer. Because on paper, the website is pretty simple, but as soon as you have to operate it, it begins to be a little more complicated. And more often than that, more often than you wish, backends, it look a little more than that, like that. The operations are yelling to the corridor, saying that it doesn't handle the load, obviously, or maybe the web server crashed again, it's unavailable for the clients, the application doesn't scale because you didn't use microservices on Kubernetes, or whatnot, it lags, latency is too high. In one word, it's fire. And that's not because it's complex. It's because you overlooked the real targets of your production. Does it ring a bell to you? Raise your hand if you already had that in production. No one had any production issues regarding the non-functional requirements? Wow. Okay.
So I'm impressed.
We are doomed with this kind of projects. We have often this kind of projects where non-functional requirements are not clear. And that's what we will see. How to be part of the 31% projects that succeed. Of course, we won't bring you the silver bullet of magical projects that always work, but we think that the first thing that you can do, and the first thing that we tend to do now with our experience, is to go beyond the functional requirements and ask truly what are the technical requirements underlying. This allows to draft the simplest design possible that will allow to sustain the business and adapt the design costs to the business value that we bring. To illustrate that, we brought two projects, one which requires an availability of 24/7 and beyond if we can, and the other one which requires an availability of the client doesn't know. And for that, we will be your guides. So we are coming from France, and my name is Philippe Duval. I'm a cloud architect, former software architect, and former production guy.
And let me introduce myself. I'm Alexandre Touret. I'm a software architect at Worldline also. Just to cut long story short, Worldline is the leader in the payment industry in Europe. Most of the time when you pay online or in stores, you use your platforms. Let's start the business presentation now and go back to our story. Now we will dive into some definition that will be useful during this presentation. First of all, as the first technical constraint, the first non-functional requirement, it's important to dig into what will be the volumetry of your platform. First of all, you must identify what will be the data you store, the data you use. For instance, if you provide an API, what will be the size of your payload? And then it's really important to know what will be the response time. And more important, it's really you have to check what will be the response time, for instance, for large pages, for small pages, for large APIs, or with large results, and so on. And it's really beyond just the average. It's really important to get also the 19th percentile or the 95th percentile, for instance. It's more essential. In the same way, you can check out what will be the number of requests per second of your API. In the same way, it will be really important to just go beyond the simple average of your platform in this category. For instance, getting what will be the peak usages for the Black Friday or for the special Christmas offers. Now imagine we have a simple application based on an API, based on the backend, exposing APIs to a front end, and this front end was used by user through a browser. First of all, you must define what will be your objectives in terms of service level. For instance, 99% of the web pages must be loaded in less than 2 seconds. To get this objective and to make them real, you need to set up some indicators. So, for instance, you can get all the time capture from the HTTP server logs. Last but not least, it's really important to set your agreement, your service level agreement. It's just a contract with your customer. Based on that, you can define what will be the availability of a platform. And what is the availability? It's just the capacity of a software to provide a service when the user needs it. And the last part of the sentence is really important. Because imagine you are currently designing a platform for a call center which is only open from 8 a.m. to 8 p.m. Perhaps the availability will be just restricted to the specific time slot. You get on the right some correspondence between the availability and the authorized interruption time. You could see that at 90% availability, you are authorized to stop your application for 46 days. But you can see that from 99% of availability, as a customer point of view, once your platform is started, it could not be stopped anymore.
That's very cool when it works. But then we still have production issues. Sometimes really bad things happen. And then, if you go by the book, you have several definitions framing what you can do when things go wrong. It's based on the DRS concept. So for disaster recovery sites, when a disaster happens, for example, when US East 1 is down, where do you redeploy your production to be back up again? This will go along with the notion of recovery time objective. How long will it take to get back in business? Maybe it can be 1 hour, maybe it can be 1 day. It depends on your business, of course. It depends on also on your capacity to redeploy your platform. And finally, the recovery point objective, which is the amount of data you allow yourself to lose while the incident happens. Basically said, before crashing, I allow myself to lose the 5 last minutes of orders, for example. More often than not, this is 0, and you don't allow yourself to lose anything. And this can be very complicated. So that's for some definitions that you will find, and in particular, the public cloud providers. They explain you their SLAs using that. But there are a lot more non-functional requirements than just those ones. In fact, there is a whole ISO standard describing the non-functional requirements that you can get. For example, portability is one non-functional requirement that you could get. Recoverability and performance handles a lot of things also. So every topic in this category can justify a deep dive. Let's just skim with the availability. For that, let's take some examples. The first one is an application that is required to be available 24/7 and beyond. That's quite common, from my experience, to have clients that come to me and say, okay, I want it to never crash. Okay, let's see what we can do about that. Let's take an example, a totally fictional example, not based on a real retailer at all. My client is a kebab supplier, and he wants an application to order kebabs and allow me to pay my kebabs. He has a very clear requirement when we first met that this application must never crash. 11.9s, whatever you can do, it should never crash. And me, I'm really a simple architect. As soon as I heard that, I figure out that he has the best kebab restaurant in the world. And I'm pretty sure that we require the top-level application. And for that, I will put in place an architecture that is top-notch, okay? So I assume that maybe there are several microservices where you can order the kebabs, you can get your favorite sauce as soon as you enter the restaurant, and it's used by the customers, but also by the people, the staff in the restaurant that bring you the food, the people in the kitchen that prepare the commands, and so on. So a lot of services using a lot of resources under that. I will implement that on GCP, so on Google Cloud. I choose to have something that is quite reliable based on App Engine, which has quite a high SLA of 99.95. It's not 24/7, 100% of the time, but it's quite high already. And since I want my database to never lose any single command, I will use Spanner, which has an SLA of 4 nines. I'm very happy with that, because my SLA must meet the client's requirements, right? Well, wrong. Because the first thing I should do here is challenge this requirement and say, okay, what is the risk you want to mitigate? Is it really that your application should never crash? Here, the requirement is not that. The requirement is that, in fact, there is only one person in the restaurant, and this person should never have to reboot the server or deal with a non-working application. It's none of their business, and the application should only not go through the way of ordering. Basically, we can perfectly order at the desk, and it will be fine. What I can do in this case is have an application that auto-remediates and heals itself. And I can have a really simple architecture with a good old monolith, and then my architecture boils down to that. I use Cloud Run with a container, it works fine. And then I use Cloud SQL. The SLA is way lower, okay? Cloud SQL alone has no SLA except if you deploy on high availability mode. But as it auto-remediates, it allows me to be sure that my client will never be bothered by my application. And this has a very high financial impact. If I use Spanner, it's about 72 euros per month, but App Engine is pretty expensive. And here I'm down about 800 euros. I let you do the math for the local currency. It's quite expensive. Cloud SQL, to the contrary, is cheaper than Spanner, but if I use Cloud Run and if I ask the right questions regarding the availability and when my client need my application to be up and running, meaning I need that when the restaurant is open, I can even use the free tier of Cloud Run, 0. And here you see that my foreseen architecture is 21 times more expensive than the client really requires. So sure, I should ask first and forehand what is the real risk he wants to mitigate. But here I'm already lucky because he said something to me. There are worst case scenarios where I don't have any clue on that.
And now for something completely different, we have an application where we don't know any key figures, any non-functional requirements. We just know that our customer would like to create an e-commerce platform for French local products, enable customer to buy online and ship and deliver them at home. Period. So after having a chat with the customer, we guess that, okay, the customer would like to be successful within 1 year. He would like to provide several offers for Christmas, for Black Friday. So as an architect point of view, we guess that, okay, we need to start fastly and deal with the scalability also to meet all these kind of requirements, if I would say. So how to do that? How to start? Decided that, okay, we need to improve our time to market, so it could be nice to use Lightful technologies. We need also to deal with scalability, so perhaps you could introduce a bit of event-driven architecture. So for that, we decided to ship our application on top of AWS using AWS Lambda, broadcasting message through AWS Kafka. And we also decided to store the data into S3 for the invoices and DynamoDB for the rest of the data. All the APIs were exposed through an API gateway. So what about the e-commerce platform? It worked well, by the way. It was really successful within just a couple of months. And the platform worked very well. It scaled really well. But one thing we didn't expect is that the cost scaled too. And we forgot that. If you already read this article from the Prime Video tech blog, normally it should ring a bell for you. Prime Video moved from a microservices architecture to a monolith to reduce their cost by 90%. And by the way, they also improved their scalability and resilience. The most important thing in this article, in my opinion, is that they don't say, okay, forget the microservices and go back to the good old monolith. They just say, okay, these technologies are really useful when you want to start fastly, when you want to improve your time to market, but it's really important to adapt your architecture and to check if it's still relevant over the time. So now, based on that, we decided to move to a good old EC2 instance, and we kept the same databases at the API gateway. So now, why these failures? Because we can consider that these two applications failed. First of all, the non-functional requirements were fully aligned with the business domain. For the latter, the cost management wasn't considered at all. There were any roadmap about what about if you double the number of users, what about if you triple, and so on, regarding the scalability. So now, propose to fix these applications.
We have an approach for that. It's not rocket science, it's just based on our experience and the thing that we do when we face a new project or a migration project. It's basically built upon five big pillars or 5 ideas. The first one being that you need to understand the business requirements. It can seem contradictory with the title of the presentation, but yeah, the non-functional requirements comes first and foremost because you have business to support. Then, once you have business to support and you understand it, you can put the real technical goals that your platform must sustain. Then one thing that is often overlooked, to our opinion, is to ask your ops what is going on the existing platforms. If you have this opportunity, it's very valuable material to understand what is the real deal of production. This will lead you to identify risks that your production must sustain and how you will mitigate them or you will live with them. To be able to ask yourself the question and ask your client the question, is it worth it? Do we spend all this amount of money to have this architecture just to sustain this part of the business? And maybe the answer is not as easy as yes, of course we do it. And this is an iterative cycle, meaning that you will go to your client and ask for refinement on the non-functional requirements. So let's see how to do the first one. Some non-functional requirements, you are very lucky because they come for free. You don't have to ask anything to your clients because sometimes you have regulations on your market. For example, here I have put some regulations that you can find commonly on several countries. If you work on the health domain, you have the HIPAA that is quite known on the United States. Going from France, we have the same, roughly the same, and I assume there is exactly the same in every country, that enforces some non-functional requirements from the regulations. For example, the use of hardware security modules in your platform. If you work in any sensitive domain in the Europe, you have the CRRD regulation that identifies critical business that needs to have some security around it. In France, we have also some rules along that, and there is, if you know the German market, there is the CRITIS standard that is also around identifying critical infrastructures. For example, if you work with the electricity domain, you need to have some regulations. And last but not least, if you work in the payment industry, you have the famous PCI DSS regulation. On Europe level, you have the PSD2 regulation that all come with some impacts on your non-functional requirements. Sometimes they are not crystal clear, but at least they are given to you for free. Let's take an example. Let's assume that my kebab industry is a critical service in the European sense. I need absolutely to be able to deliver kebabs whatever happens to my platform. You may argue that kebabs is not that critical, but coming from France, we have some specialties that are called French fries, which is quite critical. So let's see how we could do that on GCP. Could look something like that, so I will not deep dive into this, but let's back up a second. I will probably need to have two regions to be sure that I can have my business restarted as soon as possible on a second region. For that, I will use products like GKE multi-region, so GKE Enterprise, which has a quite high SLA of Quad 9, and Spanner multi-region, which has 5.9 SLAs. With that, you are pretty secure. There is one trick, though. If you consider the European regulation, it's fine. If you consider any country regulation, maybe you have territoriality, meaning that you need to be in your own country, and there is only one single region in France. So we have to admit that French fries in reality come from Belgium. So here I'm safe. I can deploy on two regions, and that's how I will do my non-functional requirements. But most of the time, my clients don't have any regulation, and they come with other non-functional requirements that are to be identified. And here, the key point is that what they know is the business value that they want to bring to their customers. And I have to figure out what is the maximum costs that I can put in my operational expenses on my infrastructure to be able to sustain that. And this is a balance to find between the business revenue and the operational costs of my infrastructure that will sustain that. And my infrastructure, my architecture, up to the application level. Meaning that if you have a very tight business revenue, microservices and all the fancy keywords that you can find on the internet may not be the ideal solutions because they will cost you just because the developers that know that will cost a lot. The idea is that it's basically a game of money. You have to go back to the money that you bring into revenue and the money you expense to sustain this revenue. And asking these questions about money is the core thing of non-functional requirements identification. Now that we know we will talk about money, let's talk about something more technical.
Okay, now we have in mind more or less all the functional requirements. It's time to deep dive into what are the technical goals. First of all, you must remember that you must not take any technical requirement for granted. You must challenge all of them, even if it comes from your customer or your organization. For instance, a couple of years ago, I had to design an application for a customer which aimed to create a file ingestion platform with 3 nines of availability. With this kind of availability, I had to design 2 data centers and 2 active data centers, and I struggled with many points such as data replication, data consistency, and such like. After having a chat with some of my colleagues, we saw that, okay, maybe it was overcomplicated. And maybe shrinking and downgrading the SLA from, for instance, 99.5 or 99.9 availability to just 90 availability, and 90% availability is really huge, by the way, was enough for the customer. Remember the table at the beginning of his presentation? With 90% of availability, you are allowed to stop your platform for 36 days a year. So how to convince my customer? So I came up with 2 designs. The first one was for 90% availability. The second one was for 99.5 availability. So I came up with 2 architectural design studies with 2 cost estimations. And I asked him first, okay, could you afford 36 days of iteration time a year? After 1 hour discussion, okay, he admitted, okay, yes, I can afford it, hopefully for me. And then I explained that starting from the simplest design architecture possible would be the best way. Because in the coming months or the coming year, if it's needed, it could then upgrade the SLA. The other way around would be impossible. Once you start with for instance, 2 active data centers and all the rocket science stuff and such like, it will be impossible to downgrade your SLA. To help you in such an exercise, you can base your studies on some characteristics. Here are some characteristics that could be useful, and they are based on our experience. Think firstly about simplicity, evolutivity, and modularity. It's very important to start as simple as possible with boring architectures. Think about KISS, keep it simple, stupid, but have in mind how to upgrade your application, how it could be evolved through the years. For instance, if you double your number of users, if you upgrade your SLA. Then the modularity. Normally, if you move from MongoDB to PostgreSQL, you won't break the whole platform. Then, think about performance and cost at once. Because if you provide the most performant application, if it costs twice the price, it won't be accepted at all. The fault tolerance is really important nowadays, even more because we deploy cloud-native applications. And the testability, for me, is a good smell. Because if it's hard to test, if your platform is hard to be tested, maybe you failed in some point, such as the simplicity. So why working with these characteristics? It will help you to create the minimum viable product with the simplest design possible. Don't be a rocket scientist trying to prevent every risk, every failure possible. No. powering the most simple design possible. But you must have in mind that your platform must support the changes over the time, after 1 year, 2 years, and so on. If you want to dig into this particular topic, I strongly recommend the book from Neil Ford, Building Evolutionary Architecture. It's really insightful.
Okay, one characteristic that you may want on your application, of course, is resilience. In that, we talk a lot about availability. Availability at the core is your application being able to cope with whatever incident you have. From a database perspective, it's very simple. I mean, you take Oracle real application cluster, you deploy it on your VMs, and that's done, right? Okay, except that I have no unlimited money, and that's here the key point that I pinpoint earlier on. Oracle RAC is a perfectly viable solution if you have the money to put on it, and this goes along with every solution that we can put in place that has a high availability by design, and that requires a lot of money. If your incoming money is not on par with that, it's the wrong choice, plain and simple. So how do we do that with no Oracle licensing costs associated, let's say? First thing first, on your services, you can think about a shift in paradigm from high availability to auto-recovery. That's what I explained with my kebab application. If you use GKE, so if you use Kubernetes at some point, it's far easier to fine-tune your application to be able to restart automatically rather than to have a lot of instances to be sure that it never fails. Because auto-restart is built-in GKE and built-in in Kubernetes. And now with Quarkus, you can start bleeding fast. So it's quite an easy solution to have something that is resilient to any failure. Let it restart, and that's exactly how we deal with Windows issues. So by the way, it should work. That's fine for the services, but for the data, it's a little more complicated. Maybe you are familiar with this, maybe not. Let's just skim on it. The CAP theorem, or more precisely the PSE-ELC theorem, is basically explaining that from a data point of view, if you deploy your application on several data centers or several servers, from a data perspective, there are several ways it can handle the consistency of the data. From one side, it works okay? Everything's fine. You still have to choose between two servers responding, bleeding fast, okay, I have the data you need, and that's it, or the two servers talking to each other and saying, okay, the right data is this one, I have this version, okay, we are synchronized, and then give it back. So you have to choose between low latency and consistency of the data that you query. Same for writing. On the other side, what if the 2, 3, or normally it's 3 cluster members cannot talk to each other? Then you have to choose between my data is consistent, but I won't give it to you, or okay, this is your data, but maybe the other part of the cluster that I cannot join has another version of the data, and you don't know what is the good one. So here we are talking about trade-offs between consistency, availability, latency. Basically, data resiliency is two distinct problems. One is called split brain, meaning when your database system doesn't behave correctly, is unable to communicate. How do you deal with that? And when it communicates perfectly well and when it's running perfectly well, you still have to choose between low latency and consistency. And most of the time, let's face it, we choose consistency. And this can be very complicated to deal with because consistency, in the payment industry, we want consistency, of course, but we also want low latency. I don't want you to wait uselessly with your card in front of the terminal. For that, we have several architecture patterns that can help you mitigate that without having to rely on infrastructure and expensive hardware. First thing that we always do on our platforms is setting timeouts wherever they can be set. It's often the case that you implement an HTTP connector without any timeout setup. It's the default one, okay, no timeout. In this case, if anything goes wrong, you are waiting eternally. And you will pile up the transactions, you will pile up the connections, and at some point we will exhaust your connection pool. So if you set a timeout, you are sure that you won't exhaust this precious resource. And then there are basically two sides. Either your downstream services are mandatory for your transactions or your data processing, or they are optional. If they are optional, you can have circuit breakers, meaning I call a service for my client, it's not there. Another client call comes, it calls again the service, it's again not there. For the third client, I might not call this service. And this way, I will fail fast, and my client don't wait until the timeout to have a response that tells him, no, it's not available. For that, I need to have graceful degradation, meaning that I must be sure of what my most minimum viable product is, and what is non-viable, not vital, I will degrade it and maybe have some process to cope back with that later on. For example, if I go to the kebab and I want some fidelity program, okay? If the fidelity service is not up and running when I order, it's no big deal. I can always have my points later on. So it's not something critical. Graceful degradation will perfectly work in that way. Then, if it's critical that the payment services, for example, I can put retries in place. But in this case, it's very critical that I don't hammer down the service, because maybe the service that I try to call is slow for a reason. It's already dying. So if I put more pressure on it, of course it will die faster, and then I really screwed because my whole platform is dead. Here, what I put in place is retries and exponential backoff, meaning that I will retry the first time after 10 milliseconds, then the second time after maybe 50 milliseconds or 100 milliseconds, and then the third time after 1 second, to let the downstream service go back running. So that's basically some tools on your architecture that allow you to avoid the Oracle cost.
And now it's time to get insight from your production for adapt your design. Now, how to know what is under the hood. I talked earlier about supporting changes. Philippe talked about dealing with latency problem. To know that, you must get insight. So first of all, you must think about observability by design from the earliest steps of your project. Nowadays, it's more a feature than just a bunch of tools you ask to the production to put in place a couple of weeks before going into production. What are the topics we can find in the observability? First of all, you need to get the dashboards. You need to get alerts based on some metrics, for instance, with Prometheus and distributed tracing provided by OpenTelemetry, and the logs. And most of all, you must get insightful logs with the business context. For that, you can use plenty of distributions, such as the Grafana Stack, Elasticsearch, and so on. Getting insights of your production means also to get insight from the people who operate with the production. You must have in mind, and you must adapt your technical choices to their skills. Okay? If the ops crew are really confident, for instance, with Kubernetes, with GKE, perhaps it will be the good choice to deploy your application based on that. On the other way around, if you propose a solution, you are really confident that yes, it's the smartest solution to put in place. You must onboard them from the earlier step, okay, to check and to make your deployment the smoothest. Now, to to check to see what will be the most precise, the smartest solution to put in place. For instance, if you have to reach an external services, should we use a circuit breaker, for instance? Should we use asynchronous messages? How to know that? You can you can base your way of thinking, evaluating the risks. How to do that? With such a typical risk analysis matrix, when you categorize all the risks in terms of probability and impact. You can check out the website from Simon Brown, rigstorming.com, which explains how to do that. You have in the green boxes all the risks you can afford. It's not necessary to bring over complexity to these issues. In the red boxes, you have all the risks. You must find a solution. It's quite mandatory. In the orange boxes, you have all the risks you must mitigate potentially. You must evaluate them first. For example, for the French local products e-commerce platform, we identified one risk, the database access issue. Okay, we evaluated it as a medium in terms of probability, and impact has very high. So how to mitigate it? For instance, putting in place high availability mechanism for the first step. So we reduced the probability of happening. Maybe in the next steps, in the next iteration, because it's an iterative process, we will try to reduce the impact by putting in place, for instance, a web cache. If you want to deep dive into this process, if you have already embraced the SRE methodology within your organization, you can also base your reflection on the work budget of your SRE. Normally, the SRE have such metrics when they evaluate all the error budget. You categorize all the risks. For each risk, you identified what will be the bad minutes per year based on the time of detection and the time of resolution. And then you can see that a risk is affordable regarding your error budget and regarding the target availability, by the way.
Okay, now we have the risks, we have the technical requirements, we have the budget that we want to spend. I can go back to my client and say, okay, you want this level of availability for this functionality, is it worth it? For example, do you really need this mobile application to order kebabs? Because if I want to host this mobile application, there are plenty of risks associated. It will cost a lot. And maybe the drivers, the financial drivers, are not there. And I can safely say, okay, we cut this part of the project, and then we can focus on other things.
And then does the question of past witnesses requires more than 3-9 availability? Is it worth it? I don't know. We must challenge it.
So just to wrap up, what we've seen, basically, we need to get clear and fitted technical requirements. So even if you just have some clues about what your clients needs, it's worth having a talk about them, what is their real requirements in terms of availability, in terms of resiliency, in terms of durability of the data, and so on. Just to be sure that you are on par with that. Then, a pragmatic risk management assessment will get you a long way in understanding what are the fears of the client regarding these non-functional requirements, and maybe lower the risk while staying cheap. And the key here is to be simple in the design. So don't over-engineer the best solution to mitigate a risk that will never happen. And stay free to evolve, to be able to cope with new risks that come with new functionalities and new business. If you already operate platforms, you have plenty of material here to do that, because the ops have a lot of return on experience on what goes wrong on the platforms. So the actual risks that happen. So it will help you gather and pinpoint the risk that you can suffer on a new project and build a knowledge base. And this is critical for the new projects, but also for the project that you are migrating. So talk to your ops as soon as possible when you are facing non-functional requirements.
So now to sum up, first of all, dig into the user needs. It's really important to have them in mind and to understand them. Pinpoint all the requirements, functional requirements, technical requirements. Then don't be a rocket scientist. Try to create the most boring architecture possible and with the simplest design. And then think about what we presented today belongs to an iterative process. You must repeat it. Even if your application is in production, for instance, don't hesitate to reevaluate all the risk after a couple of months after the application is in production. As a key takeaway, if you can sum up this presentation in just one word, you can say challenge. Challenge the user needs, challenge the user requirements, your organization requirements, even more, your own biases. Thank you very much. I don't know if you have questions.
Wait a moment, there is one.
Should I refresh the screen? How do you prevent closing doors to possible evolution to meet more complex requirements when designing simply for the start? Okay, great question. Most of the time, I present the cost estimation besides the design. And it will help my speech to be heard by the managers. No other questions? It's okay? Thank you very much.
Thanks a lot.